In this video, we are going to see about error handling in JavaScript. So JavaScript, many times you have seen some errors because of your syntax error or the semantics and structuring of the statement which you are creating in JavaScript. So because of any reasons, the errors can come. Let's see first of all a few errors, common errors which we encounter, and then we are going to see how to resolve them in JavaScript, how to properly handle them. So one of the common errors is, let's say you have simply no variable x and you are trying to print it, right? So you'll get, yeah, x is not defined. That is reference error. Next, you can have, yeah, I have x, but that x is something which I cannot assign. Let's say it is 5, and I cannot reassign it to some other value, but I do that. So it will say that it's a type error, assignment to constant variable. Okay, we will see all of them one by one how to handle it. So let's keep a track of them. So one is this one, second one is this one, third one we'll see if you have an object and let's say you intend to create an object, but you thought that later I will create, right now it is unassigned, but you forgot to create it, and some value, let's say it is there and you are trying to access that, but right now it is undefined, right? So it cannot access value of undefined. In fact, if you have any invalid value uh, which has no value, then it will not throw always an error. But if it is something like null, okay, so the thing is that if it is an empty object, for example, still if it has no dot value, then it will show you that, yeah, that thing is undefined. But but if you have something like null or undefined, then it is going to throw you an error. So this is one of the other errors. Okay, so yeah, and sometimes a value is there, but you don't, but it is not what you expected it to be. So for example, let's say const func, some function you are creating, and that is some function that is fine, and it can return 10, 20 or nothing, that is fine. But then you are trying to call this function. So yeah, right now it is fine, it is a function, but what if you forgot to define it, or you defined it but it is some invalid value? So it's not a function, it's just a number, but you're calling it, right? So in this case, when earlier it was not defined, it's like yeah, it's not like missing initializer, so that's not a proper function. And in this case also it will say you that whatever you are calling, that thing is not a function. Okay, so yeah, this is one of the ways. Some other ways you can see in which error is thrown, where let's say you have an array and you are using some inbuilt constructor, and we earlier saw that, let's say 5, 10 something is there, then it is going to be an array with elements 5 and 10. But if you only provide a single argument of to array, then it is just going to provide you an array with five empty items. So its length, as you can see, that it will be 5, but that all those 5 are empty slots. And if you pass 0, then what is ARR? Empty array, that's fine, no items. If you don't pass anything, then also it treats it as if you have passed 0. But what if you pass some invalid values? Let's say -1. You cannot create an array of length -1 or something. Then it shows you that it's a range error. This is an invalid array length value. Array length value cannot be negative. You will see that every time you are trying to do something like this, all of your code after that is crashing. So if you want to prove that, you can do something like that. Let's say I log A, I log B. Inside that I am writing these things. So either you can write the whole piece of code inside this, that is also fine. So you see that A is printed. After that, this sort of my code crashed and B never got time to print it, right? Or you can have something like some function, let's say foo, and you have defined this function yourself somewhere where you are writing all these things. Here also in the case, A will be running, and then you can see that the program has crashed, and then B got never a chance to run. However, what we want is that we want to handle it properly, so that after A, if there is some error here, then I can gracefully encounter it. I can print something on the screen, that is fine, but it should not be that my next piece of code should not execute, because if that happens, then you can understand that if a large code base is there and anywhere a single error has happened, and you have not handled it properly, then your entire code base after that crashes. Like nothing. If that piece of code crashes, then your entire code base after that will not execute. So that is not definitely what you want. So we have to handle these scenarios. One another thing we saw, that yeah, we earlier saw that we can do something like uh, JSON stringify, JSON parse. So let's keep all these things here only. We'll see one by one later how to handle them. But yeah, let's take something like you are doing something like JSON.parse, and you are doing yeah, so you are doing true in quotes. So yeah, that is a string. That is fine, right? This evaluated to, let's say, const abc is equal to, and then you printed that value, whatever is the resolved the parsed value, whatever. So abc, you are trying to print it. But as soon as, so right now you can clearly see that abc is a string type of abc. It's a string. But let's say it was not in quotes true, it was simply true. Then also in this case it is valid. It is a true. It will give you a boolean value, right? Because true is a valid keyword in JavaScript. However, if true instead of true, let's say some hello is there, then you're thinking that I'm trying to create a hello string, but that is not the case, right? You have to keep it in quotes. If not, then again the program is crashing. It is saying that I cannot parse, I cannot understand this thing, what you have written, unless and that is a proper keyword which is valid in JavaScript, or a particular value which is valid in JavaScript, or you are telling that it is a string, right? So inadvertently, if you did something like hello simply in quotes without in double quotes, then that will also crash. So yeah, later we'll see how to resolve them. So this is also an example where it is crashing and B never got to a chance to execute. Apart from all these and many other errors which you can encounter in JavaScript, there is a common way to intentionally throw error. So let's say there is no invalid value as of now, but let's say you are trying to, you have a value, and then you're trying to let's say here we saw one example, right? Here we saw one example. So later we'll see how to resolve this JSON parse. Here we had earlier an example that yeah, this thing was not null. This thing is a valid value 10. So it is treating it like obj is some number object, but number object I don't know, it has value of. So these things is fine. But if you did something like simply dot value, like this is unintentionally you wrote something like this, then it is not throwing error, right? It is just saying that it is undefined, right? Then in that cases you can yourself throw an error, right? That if let's say this thing is undefined, then you can manually throw error. So something like throw error, and you can pass an argument throw new error. So actually throw error will also work, but sometimes the constructor needs to have a proper new value. So actually you see that this is an error. This is an error. So you can see that it is throwing properly, but you should always have the practice to use new in all constructors. So you can see clearly that this is not a not a proper not a proper way to we actually had some error, but that error was not intrinsic to JavaScript. JavaScript just gave us an undefined value, but we intentionally threw an error like this. And anyways, you can do directly that sort of error here also at any level without conditional also. So that is also fine. It's just that again, this is also like not what we wanted, because we want to run this piece of code also. We don't want that after crash nothing is executed. Okay, so let's see how to do that. we can uh, we can use a construct called try catch in JavaScript. So in try catch, what happens that any code which you think is susceptible to crashing, right, then you put that inside try block, and then after that you use a catch block, and if some error happens in this piece of code, right, then your catch block will be executed. Okay, so it is something like this, that right now let's comment this and let's write simply here try and then catch. Okay, so what is happening is that let's say let x is equal to 5 or 10, and I'm printing console log x and log there is an error. You can see that no, there was no error, right? This piece of code tried to run it, and it ran perfectly. No error was encountered, and that's why the catch is never encountered, never came in the place. First thing you have to understand that you just cannot write simply try. This gives you an error in syntax error, you can see. So you have to use catch, and there's another thing called finally, which we'll see. So either catch or finally something should be only try in isolation. You should not have it, right? Well, then there is no point. You're trying to catch it, but you're trying to see that if this code is susceptible, but then what to do after that? It is as good as not having try at all, right? So there is no point in using just that. But let's see this thing was running fine because there's no error, but let's comment this part. So I have not declared x, and now I'm trying to print x. Now you see that there is an error, and now you can see the beauty that once a is executed, then I have properly handled if something wrong goes here, and in this catch block that proper handling is done, and the code is not crashing. The code goes on to execute, so b is also printed, you can see. So this is what we want. This is what we want. Wherever you think that there can be errors, you put that in try and catch, and there is an error. But what error? So actually you can see that you might not provide an argument, but if you want to know actually what error was actually there in that case, then you can use this syntax where you can use it sort of a, it's not a function but sort of a function argument. It's just a construct in, and then you can see that there is an error, and then you can see what is that error. You can see what is that error. Okay, and now you see that yeah, this thing is printed, this whole thing is printed not because it crashed, just because I wanted it to print. If I don't print it at all, then nothing will happen, like it will silently skip everything, right? But here I'm trying to see that yeah, if something went wrong, then I want to see that what has happened, and that's why this piece of code when I'm trying to print the ER, and any you can simply use or variable also. It's like a function, whatever parameter name you want to give, you can give, that will work fine. But let's say this is like saying details that exactly at what line, which was called from what file, and what resulted in crash. Let's say I don't want these many details. I just want to know that yeah, so what is the piece of information which I have, that actually what is the error, and this is error name, like there are various types of errors, right? So this bucket of error called reference error. So I want to know, let's say the particular name of the error and the message which is there. So actually what happens that all the e uh, e objects, if you see, then they have two things. They have two things. Actually this is a this has a particular type. This is a particular type, and that particular type is what, if you simply print, try to print the, let's console let's comment this for now. If you try to print, let's say type of e, and it gives you object, and this does not help you much. So you have seen that many times everything, most of the things apart from primitive types are objects. So it does not give you much information. So there is one another way which might help you in getting to know that it is what actually what type of object actually. So there is something called e dot constructor, dot name. Okay, so now you can see that it is giving you a proper this thing name. Okay, so this is a reference error. Okay, so that is one way, where you can see that yeah, if this thing is triple equal to reference error, then yeah, it is true, which means that this is exactly what condition I wanted. One another way is something called instance of. So I can say that is e instance of. Okay, so I'm doing some mistake here. Yeah, so yeah, so you can see that this arrow is printed, right? This arrow is printed, which means that I can clearly see that this is, so if this is some other error, so for example, this is not an instance error, this is a type error. For example, this was not let, this was const, and then I assigned x to 20. Then you can see that this thing is not executed, right? Rather the else is executed. So I'm just giving you ways in which you can identify that this e is an error object, but it is not executed, it is not behaving in a way which you wanted. Then if you are somewhat sure that some types of errors it can be, then you can handle it one way, or or if in all the other cases you can handle it in another way, right? And here you can understand that, yeah, so this instance of is like one not camel case, it is like just a flat instance of everything in smaller case. That is the thing. So yeah, that will also give you true if so in this case it is false, but let's say this x was not defined, then it is not an instance of reference error, right? Right. So in this case, as you can see that if I print, then it is a reference error. But if this was like this, then it is giving you a type error. And instead of reference error, which is giving you a false, if you write type error, then it is giving you true. So and again you can also compare it like constructor name. So these are some of the ways, but the main point here is that any type of handling which you want, right, that type of handling you can do inside the catch block here. Whatever handling you want to do, you can do here. So it just informs you, and if you don't do anything, then it's fine, but the further code keeps on executing, it just does not crash. So this basically try catch block basically avoids you from crashing. And again, you can write the whole thing inside that function also. So let's say rather than writing try catch here, I'm just calling foo. Okay, and that foo thing, foo function, there I'm writing try, and I'm having catch, right? And then I have all my things inside is this, right? And then rather than having a simple just let's take the proper whatever is the function, whatever is the error we encountered. So rather than log, we can use console dot error in this case. Rather than using console error, we are printing console log, we are printing console error. Okay. So yeah, so one thing we said that, yeah, this and now what is happening, you can see that if you throw new error, okay, then its type is like simply error, and whatever the piece of message is there, that is, this is an error. And somewhere else we saw that in things like this, uh, this thing can be printed. Yeah, but again you see that too much lots of information is coming. What if I don't want that much information? I just want whatever the name and whatever exact error it was encountered, rather than having this much gibberish. This much gibberish can be helpful if you want to track where that where this error is coming. But if you are fairly sure that from where this error is coming, then you just want to handle it, right? You wrote try here, so here you are definitely knowing that whatever error came from this side only, right? Inside try only. So here you just want to know some pieces of information. If you see, if you Google a bit about error object in JavaScript, then you will see that there is a proper error object where this thing can have some sort of property like message, and you can understand. So what happens that these things might be helpful in your if you want to. So earlier we saw that instance of dot constructor dot name. There is another way where, let's say, you can write e dot name and e dot message. So whatever the error is there, you can write e dot name, e dot message. So it is coming from here. For clarifying that, let's write some arrow here, and when you do that, you can see that you are getting again that what type of error it is. So the name of the error is type error, and what is the exact message which from internally it is coming, that assignment to constant variable, that is you are doing. So yeah, that if you want a clean handling, then you can do something like this name and message can be very much helpful. And the same thing will happen in all the cases. So you can see that there is a type error. This is a custom error, right? Custom error, which means that the name will be error, that is fine, but the message will be, you can customize that whatever the message you want to give. So here I am writing this is an error, or whatever message you want to write, that will come in your final message in error dot message. And this is same thing. And again here you will see that a proper handling has been done, and that's why it will show you that this type error and function is this is not a valid function variable. Okay, and here we are getting a range error. So we'll get a range error, and we know that this is invalid array length. Okay, and in a similar manner, something like parse, if it is failing, then it will show you that yeah, there is a syntax error. So you can see that there are various classes of errors. If you are properly knowing that what classes of errors you are interested in, then you can properly compare the name, or we saw that constructor.name, or we can simply do instance of to check the instance of and handle those things. But basically the thing is that all those errors are sort of buckets of exceptions where a particular type of error or exception is placed there, right, in that bucket. That is a categorization of errors, sort of. And here we see that yeah, unexpected token, because you cannot parse it in a valid way. Okay, and B is always executed. So this is, now you can understand that this is very much important if you want to if you want your code to be robust, and so that it can run in spite of a few bit of errors here and there. Your whole code should not crash. Next thing, if you no exception is thrown, then try catch block, the catch block is skipped. We have already seen that, right? So instead of this, let's say it was a valid JSON string, then AB, and then catch whatever you are trying to do, right? Just catch will not be executed at all if there is no error in this thing, right? Even if there is no error, but at the end, let's say you are throwing some error, right? And let's say this ran perfectly, but at the end I threw some error, then that also will be caught here. Okay, so any error, whether thrown manually or from the JavaScript compiler, both will come out to be here. Okay, but some error is needed, otherwise this thing will not be executed. Now there's this second thing called try catch finally. So if you try to run some code and you got some error, then that is fine. But what if you wanted to run some code in all cases, regardless of whether the exception is there or not? Okay, then you understand what is the problem. If you don't write anything, let's say finally you don't write, you just write here some piece of code. Okay, then that code is not guaranteed to run. Uh, let's say if it caught successfully that error, right, then definitely this code will run, right? But let's say you are writing and let's say that piece of code uh, needs to be run even if your code is going inside catch. So for example, there are some things like file handling or something, right? So uh, in Node.js, what happens that you can read files inside your local file system, whatever files are there, you can open that and read that, right? So the first step is that you open that file. So you open that file, and then let's say in try block, you are trying to, let's say, modify that or write that file something, right? But and if that writing failed or something, then you want to properly handle it, right? You want to properly handle it. But the problem is that, let's say, it failed. If it failed, then in catch you can handle that. But the thing is that even if it did not fail, you want to do something. For example, if you opened a file, then you have to close a file before going to the further piece of code. You understood? So the problem is that closing of file, whether some code crashed or not crashed, in both cases you have to close that file. Because let's say if something crashed, then yeah, I will throw an error and I will close the file. But what if there is no error? Then also I opened a file, I wrote something, and then also have to close. So this, if you write something in finally, it ensures that this piece of code is always executing, no matter whether error is thrown or not. So finally, in one line, what is going to happen? If you run try catch finally, some no, there is no error. Let's say there is no error. Then simply try code will run, and then finally code will run. Catch will not run. If some error happens, then try will try to run, and wherever the error happened, from there it will jump directly to catch, and then finally will also run. Okay, so finally will run in both cases. And and you can understand that apart from the normal examples which we discussed, we can also have our own things, like for example, let's say I have an array, and let's say something like this. And I want that when my code reaches here, let's say it reaches here, it should always be an array. It should always be an array. Okay. So I can again do something like that, yes, um, if this thing is, let's say, array, then whatever the array variable, then I am trying to do something like this. Okay. And let's say a valid value 5. Okay. And if and this is some variable, let's say you're not controlling this thing, so some length is there, some variable is there, and this variable is coming from somewhere, but here I'm just creating here only. But you are creating this variable array length, right? And here if you print the array, then you see that you are saying that, yeah, this 5 length array is created, right? But what if let's say it crashed, let's say it is -1. Okay, -1, it crashed. So you are seeing that yeah, something happened actually. So this variable, let's say somewhere else it is coming, and by mistake, let's say it's -1. Then your code will crash, it will reach here, and now your ARR is undefined. You don't want that, right? Your it is undefined. So you can do something like this, that yeah, I can I can print all the errors, that is fine. But after that, let's say I can do that ARR is equal to let's say empty string. Okay. So this thing is empty string, right? So if it is fine, then it is going to be 5 length array, and if it's some valid thing is there, then also it is a valid array. empty. So at this point it is always ensured that this thing is definitely there, right? And sometimes it might happen that you don't want to assign it here, right? Let's say you are you can yeah, we have just learned finally, right? So we can do something like finally. Also we know that this piece of code will always run, right? Now here, what will be ARR? ARR will be either a valid value, error will be either a valid value, or it will be some error has happened, right? So just let's not print here right now for simplicity. Let's see here that we know that in this case ARR is undefined, but earlier case it was, if let's say this is a valid value, then it is going to be an array of 5 items. So in finally also, you know that always the code is going to come here anyways. So after try catch both are run, then one final time you can check that, let's say something like if whether it is a valid array or not. So array dot is array, do you know, see that it's now a valid array? And if it's not a valid array, then you assign it something like this. So yeah, you can do something like this also. So you can see that if I print ARR in this case, then it's a valid 5 length array, but if some mistake happened and some invalid value came, then also empty array came, right? So this also proves the point that this finally block is always executed irrespective of whether this you are going this part or that part. Here you wrote a if block, right? But you can prove this by doing this also, that let's say this arrow is written, this arrow is running right now. When error is there, then this arrow is also running, right? And you can see that if there is no arrow, if there is no invalid value, if there is, everything went smoothly and valid, then obviously catch block is not executed. But you can clearly see that this arrow is still printed, which shows that finally block ran in that case also. Anyways, it did not do anything because I already got a valid answer, but finally block executes in all cases. And a catch block and finally block must be present. So you can also do something like this. This is also fine. This is also fine. Try catch or try finally or try catch finally. But simply try, this is an error. Okay, you have to add something, either finally or catch and finally, both, anything. And at least one of them should be present. Otherwise, only having try will show you that it is a syntax error. And there's a typo here. You can throw errors from inside try catch finally also, which means that just now we saw that yeah, so some so catch, you can understand the catch will always run. It is same as like another block, but you can throw errors from this try catch finally also. So let's say from here you throw an error. So let's say throw new error, and you're writing some error. Now you see that even if you can see, and let's give a valid value so that it reaches inside, invalid value so that it reaches inside catch. Now you see that even if it reached to catch, this code ran, we reached to catch, but inside catch I printed a name message, and you can see that this is printed, that is fine. But after that you again throw an error, right? Then you can understand that this whole piece of code is again throwing an error. Okay, so throw new error, which means that now again some other try catch is needed in order to throw this. Okay, so if you would have thrown from here, then there is a catch to handle it. But if you threw from here, or let's say after the catch is finished from here, then there is no one to catch it, right? There's no one to catch it. So what happens is that you, in that case, you need to put it again inside another try catch, which you'll see later. You can nest these things. So that's the next thing, that you can nest one or more try statements. Basically the inner try statement does not have a catch block, then the enclosing try statement catch block will be used. Okay, so which means that if this thing is there, then you can write the whole thing inside a try catch block, something like this, and then let's print that not caught from, let's say, outer catch. Okay, so basically what is happening is that now you can see that inside this thing is printed, but again from that side you can see that some new error is thrown, and that new error is now caught by this outer thing, right, outer thing. And this thing is this thing is basically printed. If there was no print, no throw from here, right, then you can see that this caught from outer catch will not be executed. You can see that that is not, this is not printed, right, because anyways in this try catch, in this try block, try block ending from here, there was no error, right. There if some error, there was a error, but that was elegantly handled by this catch. So in overall this whole piece of code does not throw anything outside, right. So does not throw any error, and that's why this catch has nothing to do, and that's why this will not be executed. Okay, so you can nest this like this, but you could have also done something like that okay, I will keep this try catch only, because the sort of nesting is happening, right. And then you can put this thing in try catch, you can put this thing in try catch. Okay, so some error, and now you can see that this sum error is never printed as soon as foo is fine. But if the function foo is throwing some error, then that sum error will be printed. Okay, so it's just that you can clearly see that here directly I did try inside try. Here try has some function which in turn has some try catch, that is fine. So all those sort of combinations is possible. And one more final thing is that you can return value from inside try catch finally, and that will be the final terminating value of the try catch block. So essentially this is a function. Okay, so let's say this is some function, let's say something like is valid, let's say JSON. Is it a valid JSON or not, and then I'm going to pass a string. Okay, and let's say I do something like this, that JSON.parse I try to do of that string whatever is provided, and if some error is happening, then I'm printing the message, and that is all. But in this case, there's a function I want to get some true false sort of thing, that if it is valid, return me true, if it is invalid, return me false. So multiple ways you can do. You can do, first of all, you can do something like this, that I just return true from here, right. I return true from, so, or let's take simple cases. So let's say true, I return true from here, and I return false from here. Okay, and let's take an example. Now I know that this is not throwing anything, so let's keep it simple, and const is valid is equal to, okay, and let's print this variable, let's say in B only, that whether this thing foo returned true or false. Now in this case I have to pass something, right. So let's say yeah, let's say something like this, which is a valid object. It's a string, but yeah, this thing also fine. So foo is not defined. Yeah, I have to pass that. I change the value to that thing. So now you can see that, yeah, this is a valid thing, and if it was true, then this was also a valid thing. So which means that right now it is, but if it would have been hello, then it would be, say, false. So this is valid JSON is returning me false, and the error is printed. That what was the error? The unexpected token H. I just don't understand how this syntax is there. So the JSON.parse is saying that it is invalid string for JSON, for it to be JSON, and that's why it is throwing an error. But you can see clearly that if it was valid, then you can return directly from here also. right? And this was never executed. In order to prove that, you can see that also, that let's say log some c dot dot, then you can clearly see that even if it is valid, c got never printed. C got never printed, right? Because you just went inside and this thing is successful and you return true from here, and this after this nothing is executed, right? And or let's say if it had an error, then again c is not printed. The return thing is the basically the catch block is returning false, and that is all. Okay. And you could have done something like this, that let's say if it is successful, then I want to print c, then rather than returning from here, you could have done here, right? So if it is error, then c will not be printed. I will return false as quickly as possible, and I'll show a message that whatever the error is there. But if it is true, then we will see that a is printed, and then after that c is also printed before returning true. Okay. So the whole idea is that and if you have some finally block, right, then from there also you can return whatever you want. The point is that whatever, and in this case, since this will always run, this will all, but then also you can understand one thing, that let's say some error is happening right now. What do you think? What will happen? Will finally run? Will finally? Turns out it will not run. Why? Uh, okay, so let's see. Yeah, so basically, yeah, so let's see here. Yeah, so if it is having a return, then also it is executing finally. Okay, so if it is returning false, yeah, so you can clearly see that if you're returning true from here, let's print proper values, right? Let's print proper values so that it is because I have also not tried it before, but let's see some value returned. Okay, from inside this thing, right? Now let's return a. Okay, and here let's return b, and here let's return c. Okay, and everything is returned from either try, catch, or finally. So this will be sufficient, right? Now if everything was fine, then also you are seeing that c is returned. You understand? If a and b, and the returned value is c, even if you returned a from here. Okay, so this is like I was also not aware. So basically what is happening is that if finally is there, then this return is basically ignored. You can understand. So you can understand that if this thing I commit, let's say this thing I commit, sorry, not commit, comment. Okay, so you can see that a is returned, right? But if finally is there, then that return value is ignored. Finally value is being returned. Okay, it's good. And if let's say something is there like this, then also we saw that it went into error. No, it went. Yeah, it went into error, like catch block it went, and then after that it is going inside finally block, right? Final block. So which means that in this case also it is running. If this thing is there, then you can see that then now b is being returned, right? But if finally is there, then again that thing is given more preference. I don't know how internally they implement these things, but definitely the final return value is somewhere preserved, and if they see that there is a finally block, then they return the final return value from finally rather than whatever the preserved value from try or catch. Okay, this is good. So yeah, so hopefully you learned something from this video. I also learned a bit from this video, and let's see in the next video where we'll continue with our journey on promises. Okay, that will be all for this video. Thanks.